Hi everyone, this is Chapter 1, Section 4, Scientific Notation. For those of you that have recently taken a math course or been using math, you may not really need to watch this video. It's sort of understood that you know how to put numbers in scientific notation, but just in case, we want to make sure that all of the students know how to do this. When we deal with really large or really small numbers, it's much more convenient for us to look at them in scientific notation. And what that means is that we have a coefficient, which is this number here, number out front, and then we have a power. So here it's times 10 to the 5th power. Okay, so this would be a large number. And so this would be a really small number. So when you have a negative 8 times 10 to the negative 6, okay, that negative means it's a really small number. Okay, and then of course here is M for meters. So most of the numbers that we report in chemistry, we also have a unit. So we have meters or centimeters, or, you know, the list could go on and on of what our unit is. Okay, so I just stated this, that you have a coefficient. So if you look at the number 2,400, okay, it's not an extremely large number, but typically at about the power of 3, the number does look a little bit better in scientific notation. Okay, and so if we were going to look at this number and put it into scientific notation, okay, if we have to move our decimal to the left, bear with me a second, I'm going to get at the pen. Okay, so I always go to the very end right there and pretend there's a decimal. 1, 2, 3. I had to move it over 3 places to get that decimal right past the first non-zero digit. Okay, if I move my decimal to the left, okay, that means I have a big number. Okay, so I get 2.4 okay, times 10 to the third. Because I moved my decimal over 3 places. So 1, 2, 3. And that's just a simpler way that the way that I do it. And if I have a unit, so something like meters, I have to be sure I place that there as well. Okay, these numbers are the same. Okay, there will just be times that, especially with really large numbers and small numbers, that you're going to have to put these numbers into scientific notation. A lot of your calculators will do this for you. Some won't. Okay, so depends on what calculator you have. Okay, so this is what we just did. We moved it over 3 places, and that's the number that we got. Okay, if we look at a small number, let's see, this number is less than 1. So if we moved our decimal, get my pen again. Okay, so we move 1, 2, 3, 4. Oops, that didn't quite go over. We move 4 places. This time we move to the right. So we have a small number. If you move to the right, you have a small number, and so you're going to get a negative here. Okay, so we would say 8.6. Okay, notice how I didn't move it past the 6. I move it past the first non-zero digit times 10. Okay, that's our power to the negative 4th. Okay, if you put just a 4 there and not negative, then you're saying that you have a really big number. Okay, so when you have small numbers, you end up with that negative, meaning that you moved your decimal to the right. Okay, so here just shows you some multiples of 10, and if you have 10 times 10 times 10, that's what we're doing when we're moving our decimal place. You get 10 to the 4th, okay, and so forth. But typically, you know, if I look at the number 10, I'm not going to put that in scientific notation, okay? That's kind of a lot more work here for me to write it into scientific notation. Even, you know, 100 to the 2nd power, I'm just going to write 100, you know. Mastering Chemistry may ask you to write in scientific notation. Just pay attention to that. But when you get to the third power, or negative third, that's when numbers start getting a little bigger and may look better in scientific notation. Okay, so here, the diameter of a chickenpox virus. Okay, if I was to give you this number, 0.000003, okay, that's a lot of, doesn't look nice, it's a lot of work there. It looks much better in scientific notation. So if we go here, we move our decimal 1, 2, 3, 4, 5, 6, 7. Okay, so the small number, we move to the right. So we get 3 times 10 to the negative 7 meters. That looks a lot nicer for us. These are kind of nice little facts. They're from 2012, so somewhat recent, but the volume of gasoline used in the United States, that is a really large number. So if we move our decimal to the left 11 spaces, this right here in scientific notation, 5.5 times 10 to the 11th, looks a lot nicer. Mass of a hummingbird, so there's your negative 3. Okay, for 68, it shows its scientific notation, but once again, that's not a number that I would put into scientific notation. It looks fine just as 68. Look at this really small number, so you can go through and check these, make sure you get the same answer. We would have to move our decimal to the right 19 times. Okay, so of course this number looks a lot better as 1 times 10 to the negative 19 kilograms. Okay, when you're entering in your calculator, so I get lots of questions on this, especially if you're using a number in scientific notation and then you're multiplying it or dividing it and using it. You may need to use multiple steps in your calculator instead of trying to put everything in there at once. But typically, you want to put parentheses around your scientific notation. So you want to go get my pen again. So in my calculator, for instance, I have a Texas Instrument. And whenever I enter, so let's say this is my number in scientific notation, and I'm multiplying it times something else, I put everything in parentheses, okay, and that helps. What happens a lot of times is students will have the right formula and everything will be set up correctly, and then they'll get an answer, and it'll be kind of a crazy exponent. So you'll get something very, very different in your answer. It may, instead of being negative 3, you get negative 14. So it's only off by that power. Okay, so here's just some tips for that. Okay, if you wanted, in some of your calculators, you may have an exponential key or EE. So that's very common. Okay, and so you would press that and then put to the 6th power. Okay, if you had a negative number, you would press the exponent key and then go to your plus or minus key in your calculator and put in the negative 4. And you may have to enter it as negative 0.4. Okay, so let's put all these in scientific notation. We'll go ahead and go to the solutions. Okay, we have a large number, so we know that we're going to have to move our decimal to the left, past the first non-zero digit, so I moved over 1, 2, 3, 4 places. Okay, if it's a large number, my exponent's going to be positive, so we get 6.4 times 10 to the 4th. Right? Have a small number, it's less than 1. So I've got to move my decimal to the right. So when I move to the right 2 places, I get negative 2. So I get 2.1 times 10 to the negative 2. 138, so these are numbers that kind of look fine without scientific notation, but They're just practice. So it's a large number. It's over 1. So if I move to the left twice, that means if I move left, it's going to be a positive exponent. And I get 1.38 times 10 to the second. Okay, so that power there is based on how many times did you move your decimal either to the left or to the right. All right, thanks for watching.